Okay, so let me just turn. All right, great. All right, so today is day one of the 7-day data analysis workshop. All right, this is totally for people who have never even heard of the word data, don't know anything about data, and essentially for people who are at the medium level or any level, right? Because what we're doing is unlike anything that's been done in your program. So if you were in school or if you are in school, they teach you how to perform statistical tests, but they don't teach you how to analyze data from entering the data into your actual software program, cleaning the data, recoding the data, computing new variables. We're going to cover all of that. That's not covered in your program. So I'm going to teach you over these next 7 days how to analyze your data from start to finish. Okay? All right. Now, these are the 4 phases of the data analysis process. The first phase is the test selection phase, right? Now, so you come up with research questions and you say to yourself, hey, what statistical tests do I need to use in order to answer these particular research questions? All right. But there's a process that you have to go through in order to select the correct statistical test. And we're going to go through that process today. Then tomorrow, once we've selected our test, then we're going to go through part of the data preparation, checking for errors. That's going to be the first part. Cleaning the data. That's going to be the first part. Then on Wednesday, we're going to go through the second part of data preparation, which is computing new variables, recoding, and so on and so forth. Okay, that's the third day. Then the fourth day, we're going to look at preliminary analysis, because once we have our statistical test that we're going to run, then we're going to figure out, hey, what is the health of our data? Is our data structured in such a way that we can run these statistical tests without problems? So I'm going to teach you how to check the assumptions of your statistical test. Okay. And that's going to take a couple of days. And then the remaining couple of days are going to be performing the actual statistical tests, understanding how to run them, how to interpret them, and basically what you need to do in order to report your results. All right. If that makes sense, type in a 1. If something doesn't make sense, type in a 0. And what we're going to do, great. And what we're going to do is we're going to go through all of the steps using this workbook. So regardless of what type of software you're going to use, you're always going to use the first. All these steps are going to be followed regardless of the software program that you use. Okay. All right. And this thing walks you through step by step by step by step by step. So this is the workbook that we're going to be using. And I also have the data file here. All right. Now, does anyone have any questions before we begin? Just raise your hand or type in. I have not received my workbook. Okay. In Kese. All right, let me check on that. Did you pay for the workbook? If you did, send me a message and let me know the email address that you used to. Oh, I paid today. Okay. All right, here. Let me check. And then I will send it to you after the class. Okay. I will make sure that you get it after the class. Okay. Okay. All right, great. Any other questions? Any other questions? All right. So now, so here we go. The first step, statistical test selection, right? And you're going to use this workbook when you're analyzing data. Because when I was analyzing data as an analyst back in the early 90s, I didn't have a workbook. We used to write everything down in notebooks. But I created this data analysis workbook so that you could write everything down. Okay? All right. Now, so the first thing that you want to do, okay? The first thing that you want to do is you want to write down your research questions, okay? And they're basically three types of research questions. We're only going to be concerned with two, but there are three types. And I have them listed here. There are descriptive questions, okay? How much, how many, how often? Those are basically the type of questions when we're running descriptive statistics. We don't really use those for advanced research, okay? We have differences questions, right? Differences questions ask whether or not there are differences between groups or time periods, right? So for example, is there a significant difference between students in classroom A and students in classroom B on math tests, right? So that's a difference question. Another type of difference question is there a significant difference in pre-test and post-test measures of graduate students in a statistics class? Okay. The same students take a pre-test, they take the class, and then they take a post-test, right? So that's a time-based comparison versus a group-based comparison, okay? If that makes sense, type in a Y. If that does not make sense, type in an N. Okay. So those are differences questions. Anytime you see a question that says, is there a difference? You automatically know that's a difference question. Okay? That's a difference question. And then the second type of statistical question is relationships or prediction questions. Okay? Relationship or prediction question. These questions ask, hey, are there relationships between variables, right? Is there a relationship between variable A and variable B? In other words, is there a relationship between shoe size and height, right? That's one. Is there a relationship between ice cream sales and the temperature outside, right? That's a relationship question. Another type of relationship question is prediction, meaning, you let these people in here, meaning, does one thing predict another? Can we use one variable to predict another variable? All right. Now, anytime you see the word prediction or relationship, that's going to be a relationship prediction question. Okay. It's very simple. If somebody says, is there a difference between something, or is there a relationship or prediction? That tells you the kind of question that it is. Okay. If that makes sense, type in a 1. If it doesn't make sense, type in a 0. All right, great. Excellent. Excellent. Now, so what we're doing is the first thing is we have 3 research questions. Okay. These are 3 research questions. The first research question says, is age related to optimism life satisfaction, perceived stress, and mastery. Okay, so let's say we've done this study. We have a survey, right? So for example, we had this survey here and we sent it out to all these people and they completed the survey and we have all this data, right? And let's see, we've got the data file and we've collected all this information. And now it's time to analyze the data. So the first thing that we have to do is figure out, hey, what test are we going to run? What tests do we need to run in order to answer these questions? Okay? So the first question, is age related to optimism, life satisfaction, perceived stress, and mastery? Is this a relationship question or is it a difference question? If it's a relationship question, type in an R. If it's a difference question, type in a D. Excellent. So it's a relationship question. All right. Relationship. Second question, are optimism and self-mastery predictors of perceived stress? Is that a relationship question or is it a difference question? If it's a relationship question, type in a 1. If it's a difference question, type in a D. Okay, great. So we're going to say relationship prediction, relationship prediction. All right. All right. Very good. Okay. Oh, somebody wrote in a D. Okay. Whoa. Are optimism and self-mastery predictors of perceived stress? It's a prediction question because it's asking about whether or not a variable or variables predict or are related to another variable. Okay. Differences questions are, is there a difference between groups? Is there a difference between time periods? That's a difference question. Okay. I just want to make sure that's clear. All right. So Darlene, does that make sense? If it makes sense, type in a Y. If it doesn't, type in, okay, great. Excellent. Now you will learn from my style that, I don't leave anybody behind. I want to make sure that everybody understands what's going on. Okay? That's very important to me because I'm one of these people that I want people to understand. All right. The third and final question, is there a difference in optimism among young, middle-aged, and older participants? In other words, we gave all these people an optimism test. And we categorized them between those who were 18 to 29, that's one group. Those who were 30 to 44, that's one group. And those who are 44 and over, that's another group. And we want to see if there's a significant difference on optimism scores between those groups. Is that a difference question or a relationship question? If it's a difference question, type in a D. If it's a relationship question, type in an R. Okay, excellent. 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 All right. So now that we have successfully identified the question type, now we go to step 2. And step 2 says, hey, now we have to write the null hypothesis for each of the research questions. Okay. So the null hypothesis is simply this. There is no significant relationship or no significant difference in this study. Okay. Null means no. Okay. So whenever you're writing the null, if it's a difference question, you're going to say there is no significant difference between blah, 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 blah. And if it's a relationship question, you say there is no significant relationship between blah, 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 blah. If it's a prediction question, then you would say blah, blah, blah does not significantly predict blah, 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 blah. Okay? Null hypothesis means no. All right? If that makes sense, type in a 1. If it doesn't make sense, type in a 0. Excellent. Excellent. Now, so for the first research question, we had, is age related to optimism, life satisfaction, perceived stress, and mastery? So the null hypothesis is going to be no, it's not. So the way we write that is we say age is not significantly related to optimism, life satisfaction, perceived stress, and mastery. If that makes sense, type in a Y. If it doesn't make sense, type in an N. Okay, good. So the second research question says, are optimism and self-mastery predictors of perceived stress? Null hypothesis says no, they're not. So how do we write that? Optimism and self-mastery are not significant predictors of perceived stress. If that makes sense, type in a 1. If it doesn't make sense, type in a 0. Excellent, 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 excellent. All right, so the third research question asks, is there a difference in optimism among younger, middle-aged, and older participants? The null hypothesis says no, it's not. So then how do we write this? There is no significant difference in optimism among younger, middle-aged, and older participants. If that makes sense, type in a Y. If it doesn't make sense, type in a 0. Okay, good. And I keep looking to the right over here because I have 4 screens in my office. So the screen where the comments are is right here. I got another screen over here, and I got another screen over there. Matter of fact, and I got a screen in front of me. So, all right, excellent. All right, so now we go to step 3. And step 3 says, Step 3 says, define the independent and dependent variables. Now, there were several pre-workshop videos that I gave you to prepare you for this workshop series. And one of the videos was how to define your variables. That was one of the pre-workshop videos. There are about 7 or 8 videos. And the purpose of these videos is basically to give you a basic foundation to understand basic concepts that you need to use and know when you're analyzing data. Okay. So if you have not watched those pre-workshop videos, you need to watch them. Okay. You need to watch them. Now, so I'm going to briefly cover what an independent and dependent variable are. All right. But the workshop video covers this in more detail, in far more detail. And there's videos and pictures and everything. I'm a very visual person, so I like to explain things visually. All right. An independent variable is a variable that influences or explains another variable. Okay? It is a variable that influences or explains another variable. Okay? Another word for independent variable is predictor variable. Sometimes people use predictor variable instead of independent variable when they're running regression, okay? Or when they're using prediction questions, they use predictor variable. Now, if that makes sense, type in a 1. Independent variable is a variable that influences or explains another variable. Okay? So for example, let's say we have the temperature outside, and we want to know if the temperature affects whether or not it's going to snow. Okay, right? So we're gonna say rainfall versus snowfall. Okay, so basically we're saying, hey, the temperature outside is going to influence whether or not it rains or it snows, right? So if the temperature is higher, it's more likely to be rain in precipitation. If the temperature is very low, it's more likely to be snow. Snow doesn't affect the temperature, right? Rain isn't going to affect the temperature. It's the temperature that's going to influence the type of precipitation. If that makes sense, type in a Y. So that thing is influencing the other thing. All right. Now, the dependent variable is the thing that is being influenced. So the precipitation, whether or not it rains or snows, is being influenced by something else. Okay. We call that the dependent variable. And if you're using regression, we call it the outcome variable. It's the outcome of something. All right. Okay. So dependent variable and independent variable. Now, so first research question. We have to define the variables that are independent and the variables that are dependent. Okay. Now, let's start at the bottom. Is there a difference in optimism among younger, middle-aged, and older participants? Okay. So what do we believe is influencing the other? Do we believe that optimism is influencing age, or do we believe that age is influencing optimism? Okay. So is age the independent variable that is influencing optimism, or is optimism the independent variable that is influencing age? So if you think it's age as the independent variable, type in an A. If you think it's optimism, type in an O. Yes. So age, we believe that different ages are influencing optimism. Okay. So people who are young may be more optimistic than people who are older, right? Optimism scores are not going to influence whether you're young or old. So in other words, if I get a 13, that doesn't mean I'm going to turn 21. Like, you understand what I'm saying? We're not looking at optimism scores on a test to influence what a person's age is. We are thinking that age is going to impact optimism. So we're going to say age here, and then optimism scores over here. Okay. If that makes sense, type in a 1. If it doesn't make sense, type in a 0. Don't be ashamed or embarrassed or whatever if you don't understand something. I'm here to explain it. If you have a question, raise your hand or type in a help or a question mark, and then I will see you. And I was like, okay, what's your question? And then we can go from there. Anytime you have a question, just type in a question mark. Okay. All right. All right. So now let's go to research question 2. All right, research question 2. Are optimism and self-mastery predictors of perceived stress? Okay, so is perceived stress affecting self-mastery and optimism, or our optimism, do we believe, affecting and self-mastery predicting perceived stress? So if you think that optimism and self-esteem are independent variables, type in OS. If you think perceived stress is the independent variable, type in a P. Which one is influencing the other? Optimism and self-mastery are predicting perceived stress, right? The belief is that these particular variables are influencing. So when you see the word predictor, think of the word influence. Influence. It's directional, right? Two things are impacting or predicting the other. Okay? So optimism and self-mastery are the independent variables because they're predictors. Let me just type in something here. Right? And then perceived stress is the outcome or dependent variable. Okay? Because again, the perceived stress is being influenced by, we believe, based on this question, we believe that optimism, how optimistic a person is, and the sense of their ability to master their environment is going to influence whether or not they perceive their environment to be stressful, right? If a person has a greater sense of self-mastery, that they can go in life and master things and do better, they may be less stressful, right? Okay? If that makes sense, type in a Y. If it does not make sense, type in an N. Okay, it's very important that you watch the pre-workshop videos. They will clarify all this stuff. I'm going through this, not as deeply, but I give several examples of independent and dependent variables for you to look at. And you'll come out with a better example. I've had little kids watch the videos and understand the concept. So I know the concepts are clear because I actually tested with, So, all right. So now we go to the research question 1. Research question 1 says, hey, is age related to optimism, life satisfaction, perceived stress, and mastery? Right? Is age related to optimism, life satisfaction, perceived stress, and mastery? I'm going to throw you a little curveball. And that is 2 words, related and prediction. Okay? Relationship implies a multi-directional relationship, right? It can go one way or it can go the other way. Okay? If 2 things are related, that means that as one may impact the other, but we don't really know which one is doing what. Okay? When you have prediction, then it's what we call a unidirectional relationship. X predicts Y. In other words, X comes first, and then we believe it's affecting Y. Okay? It's a unidirectional or one-direction relationship, right? Whereas a relationship question right, that looks strictly at relationship, it's multi-directional. Okay? It can be either way. So whenever you have a relationship question, we don't have a dependent variable. We just have independent variables. So we're going to say age, optimism, life, satisfaction, perceived, stress, and mastery. Because what we're saying here is that as age increases, there's going to be some relationship between optimism scores. But we don't know, right? So whenever you use the word relationship, you're assuming that there is a co-relationship between variables, that there is no antecedent, meaning there is no variable that is influencing the other. When you use a prediction question, then you're assuming that one variable or multiple variables are influencing another. Relationship questions means that you have a relationship between both, and prediction questions are antecedent, meaning that one is influencing the other. Relationship questions are these variables are influencing each other. If that makes sense, type in a 1. If it does not make sense, type in a 0. Okay. All right. Now, so let's say we've got age and shoe size. Again, if you have a question, just type in a question, right? We say, hey, age is related to shoe size, right? So we don't really know whether or not age is affecting shoe size or whether the shoe size is more affecting the age, right? So it's a bi-directional relationship. But if we were to say, hey, your score on a test, a reading test, is probably going to be in your age is going to affect your scores on a reading test. Probably so, because people who are older are supposed to be able to read better than people who are younger, right? So again, it's unidirectional and bidirectional. Relationship questions are bidirectional. Prediction questions are unidirectional. Something is affecting the other, okay? Remember to watch the workshop videos. That's very important, all right? Now, we're going to go to step 4. Now, so here we have to figure out, we're going to figure out what type of variable how are these variables being measured, right? That's what we want to know. How are these variables being measured? And again, this is something that we covered in the pre-workshop videos, okay? The pre-workshop videos. Okay, let me before I go into step 4, let me ask you this. Does anyone have a question right now? Does anyone have a question? If you have a question, type in a question mark. Okay. All right. So we say to ourselves, okay, how are these variables being measured? Because in order to determine the correct statistical test, we have to determine how the variables are being measured. Okay? how the variables are being measured. All right, so we go to the data file. Okay, so let me open this up on one side. And then I'm going to open this up on a data file on the other side. All right. So here, levels of measurement. There are 4 levels of measurement, and they 4 fall under 2 categories: categorical variables and continuous variables. Okay. Categorical variables are either variables that serve as labels, the numbers serve as labels, or rank or order. Those are categorical variables. Continuous variables are either interval or ratio variables, okay? So an example of a categorical variable that is a label is a nominal variable, right? So whenever you see numbers on an athlete's shirt, that is what we call a nominal variable, because the number serves as to identify a label or a name, right? So, you know, your favorite soccer player, his number may be 23, or football player may be 12, right? 12 is generally the quarterback, right? It's an arbitrary number. The number itself doesn't mean anything. It's just a label. That's what we call a nominal variable. And this is explained inside of the data analysis workshop, pre-workshop videos. Then you have ordinal variables. They have the characteristics of a label, but they have order. So first, second, third, fourth, fifth. The numbers themselves don't really mean anything, but they have the purpose of labeling something and also establishing the order of things. So ranks and orders, those are what we call ordinal variables. Okay? Categorical variables are either nominal or ordinal. If that makes sense, type in a Y. If it doesn't make sense, type in an N. Okay. All right, Eddie. Okay, so let's say we've got a situation. I'm going to go through this quickly because it's in the video, the pre-workshop video. So let's say, for example, we have a person who is, let's say, students in a classroom, right? And we just give them numbers, right? So we give them, confused between nominal and ordinal. Okay, I'm going to explain it to you. Okay, so let's say there are 10 students in the classroom, and we just randomly assign them numbers. The numbers don't mean anything. They're just labels. So John gets a 1, Susie gets a 2, Linda gets a 3, just arbitrarily. That is what we call a nominal variable, okay? Because the numbers don't mean anything. They're just labels. All right? Do you get that so far? If that makes sense, type, okay, great. Now, here's where the ordinal comes in. Let's say that Robert is the tallest person in the class, and then Linda is the second tallest in the class, and then Barbara is the third tallest in the class. Okay? The tallest student would get 1, the second tallest would get 2, and the third tallest would get the number 3. It's still a label, but now the numbers represent an order of something. Does that make sense? So, got it. So it's purely a label, nominal, but it's a label indicating some order when it's ordinal. Okay? Does that make sense? Okay, great. All right. So now what we're trying to, is it too late? I need to pay the recording and book. I'm going to have an opportunity for you to get the book and the recording right after this class. Okay? Right after this class, I'm going to give you an opportunity to one last opportunity to get it at the discount price, but we'll talk about that later. I just want to finish this up. Okay? So anybody who wants to do that, you can do that later. You're very welcome. All right. So now we've got age, right? So age is measured in years. Okay? So years is what we call a ratio variable. And a ratio variable is a variable that is continuous, that has an absolute zero. That means that if zero is relevant in this variable, it is the absence of the characteristic or the phenomenon. So age is ratio because 0 years old means you're not born, right? Well, it could mean you're 6 months or 8 months, but you understand. It's basically you're not born. So it's basically a ratio variable, which is continuous. So we're going to put continuous ratio, okay? Then we have optimism scores, okay? Anytime you have a scale, okay, like a depression scale or optimism scale, self-esteem scale, all scales are going to be interval if they have at least 4 options, okay? All scales are going to be interval if they have at least 4 choice options. If that makes sense, type in a 1. If it doesn't make sense, type in a 0. All right? So any scales are going to be interval. So we're going to type in continuous interval. Life satisfaction is another scale. Okay? So we're going to type in continuous and it's interval. All right? Mastery scale is another scale. So it's going to be continuous and interval. All right? And all of these, as we said before, are going to be independent because it's relationship. Remember, a bidirectional relationship. When you see the word relationship, it's a bidirectional relationship. When you see the word predictor, it's a unidirectional relationship. Something is affecting another. All right? Now, so here, and again, you can do this with any study that you're doing. You just fill in the information. Are optimism and self-mastery predictors of perceived stress? Again, optimism is a scale. So it's continuous and it's interval. Why is that? Because we see here, we see optimism scale has 1 is strongly agree, strongly disagree to strongly agree. So it goes from 1, 2, 3, 4, 5. So there are 5 options. It meets the minimum standard of 4. Does that make sense? If that makes sense, type in a Y. All right, great. Mastery scale. It's another scale. It has 4. Strongly disagree, all the way up to strongly agree. So it's got 4 options. Life satisfaction. It has 7 options. It goes from 1 strongly disagree to 7 strongly agree. Right? Perceived stress. It has 5 options. 1 never to 5 very often. Okay? So these are all scales and they have at least 4 options. So they're interval. They're always going to be interval. So the mastery scale is going to be continuous interval. And the reason why it's interval is because it does not have an absolute zero. So if a person scores a 0 on a satisfaction test, that doesn't mean they have no satisfaction. It just means that, it doesn't make sense. So it's either low satisfaction or higher satisfaction. All right. So interval, anytime you have a scale, 0 doesn't make sense. Sometimes they may label something as a 0, but 0 does not represent the absence of satisfaction, the absence of depression, the absence of perceived stress. It has to be something that's tangible. Feelings and emotions, there's no such thing as a 0 emotion. It's just emotions are something that are on various levels. Okay? If that makes sense, type in a 1. That's why scales can never be ratio. They always have to be interval. All right? And then perceived stress is another scale. So we put continuous and then interval. Optimism scale. It's continuous and then interval. All right. Now we have age group. So let's see. Age group is 1 equals 18 to 29, 2 equals 30 to 44, 3 equals 45 and above. Now, let me ask you this. Is this a nominal variable where the numbers are just arbitrary? Or is it an ordinal variable where the numbers indicate some kind of order? If it's an ordinal variable, type in an O. If you think it's a nominal variable, type in an N. Excellent. It's ordinal because 1 is the youngest group, 2 is the middle age group, and 3 is the oldest group. So there's an order there. It's a label and an order. Okay. So we're going to type in categorical and then ordinal. Okay. All right. So now that we've done that, we can now go to step 5, which is select the statistical test. Okay. Now we can go and select the correct statistical test. We've done all this work, and we're going to use all this information to answer the question, which statistical test should we use? All right. Let's start with the first research question. Is age related to optimism, life satisfaction, perceived stress, and mastery? So we go to, so there's, this page has all the tests or the majority of tests that we use to assess differences. The next page has the tests that we use to explore relationships. Okay? So what we do is we do process of elimination. So the first one says, bivariate correlation used to assess the linear relationship between two variables. Specifically, this test provides information on the strength and direction of relationship. And what do we need? We need at least 2 continuous variables or 1 continuous variable and 1 dichotomous variable. Dichotomous means it only has 2 options, right? So for example, male, female, tall, short, just only has 2 options. All right. So let's go back to our question. Is age related to optimism? Is age related to life satisfaction? Is age related to perceived stress? And is age related to mastery? So age is being looked at in comparison to optimism, life satisfaction, perceived stress. And these are all continuous. Okay, these are all continuous. So the way this is done is age is examined against optimism. Age is examined against life satisfaction. Age is examined against perceived stress and mastery. Okay? And they're all continuous. Does that make sense? We see that they're continuous. Okay? If this makes sense, so let me write it another way. So basically it's going to be age and optimism. Age and life satisfaction. Age and perceived stress. Age and mastery. All right. So whenever you see this type of question, it's age in relationship to all of these individually. So let's say we had age and height, right? It would be age and mastery, age and optimism, age and life satisfaction. And then it would also be height and mastery, height and optimism, height and life satisfaction, height and perceived stress. Okay. So again, whenever you see the word relationship or related in a research question, you always have to think of it as one-on-one. One-on-one. Okay. Prediction is something different because you can have multiple predictors, but you can only have one variable and another variable when you're looking at relationships. If that makes sense, type in a Y. If it does not make sense, type in an N. All right, great. All right. So these are all continuous. So used to assess the linear relationship between two variables. Specifically, this test provides information on the strength and relationship. Two continuous variables. These are all continuous, right? These are all continuous. So this might be okay. So we're going to highlight this as a possible. Uh-oh, where's my... What happened to my... Anyway, I can't see my... I don't know what just happened to my... I did something here and I can't see my... Anyway. All right, so this is a possible. Partial correlation. Like the bivariate correlation, this is used to assess the linear relationship between two variables. The difference here is that this procedure allows you to control for or remove the influence of another variable. So you got two variables that are continuous or one continuous, and you have one continuous variable that you desire to control for. We're not trying to control for anything. There's no word of control in here. Okay, so we're not looking for control. Oh, here we go. We're not looking for control, so that's out. Where's my cross out? All right, so that's out. All right. And then we've got the bivariate regression. This procedure tells you how well one independent predictor variable predicts a dependent variable. This question does not include prediction, okay? It does not include prediction. Where is my view? I'm trying to get my, I can't see my table, my ribbon. That's what I'm looking for, my ribbon, and I can't find it. Okay. So there's nothing here related to that. Okay. So this is out. This is out. Okay. So that's out. Multiple regression. This procedure tells you how well two or more independent predictor variables predict a dependent variable. This is another thing that deals with prediction. There is no word about prediction here. It's about relationship. So we cross this out. It's not a prediction test. Okay. It's not a prediction test. So we cross that out. Used to assess how well two or more independent predictor variables predict. Dead giveaway. It's not a prediction question. All right. Multiple logistic regression used to assess how well two or more independent predictor variables predict. Another prediction question. We're not interested in prediction. We're interested in relationships only. And then finally, we've got factor analysis. It's a data reduction technique. It takes a large set of data and reduces it to factors of what. We're not talking about data reduction. There was nothing in here about data reduction. Okay? Nothing in here about data reduction. So what's left? It's not factor analysis. It's not any of these. The only thing that's left is bivariate correlation. Do you see how we did that? If you saw how I came up with bivariate correlation, type in a 1. If you have a question, type in a Q. All right. So bivariate correlation. All right. So we type in bivariate correlation for that question. Now, so then we say, are optimism and self-mastery predictors of perceived stress? All right. Our optimism and self-mastery. Optimism is one variable, self-mastery is another variable, and perceived stress is another variable. So let's go back and see what kind of variables these were. They're both continuous. They're both continuous. So we got two independent or predictor variables. And we've got one dependent or outcome variable. Okay. Are you with me so far? If you're with me, type in a Y. We've got two predictor variables or two independent variables, and we've got one continuous dependent variable. Okay. So now we have to figure out which test are we going to select. So then we go to relationship. And we say, okay, let's start here. Used to assess the linear relationship between two variables. We don't have two variables. We've got three. 1, 2, 3. So that's out. So that's out. Partial correlation. Like a bivariate correlation, this is used to assess the linear relationship. We're not really looking at relation, we're looking at prediction, and we're not interested in control. So this is out. If you're with me on how I am eliminating partial correlation, type in a Y. If you understand why I've eliminated partial correlation, type in a Y. Number one, it's only looking at two variables, and number two, it's looking at a control variable. We are looking at three continuous variables. All right. Now, bivariate regression. This procedure tells you how well one independent predictor variable predicts a dependent outcome variable. So you got one continuous dependent variable and one independent variable. We have two predictor or independent variables and one. So this is, we only need one for bivariate, but we have two. So bivariate is out. Bivariate is out. All right, multiple regression. This procedure tells you how well two or more independent predictor variables predict a dependent variable. So you got one continuous dependent variable and two or more independent variables. We've got two independent predictor variables and one dependent variable. So far, this matches the multiple regression. Okay, so we're going to keep that. And then binomial logistic, used to assess how well two or more independent predictor variables. Okay, we're good there. Predict. Okay, we're good there. A categorical dependent outcome variable. Our dependent variable, outcome variable, is not categorical. It is not categorical. It's continuous. So that's out. So we eliminate this. If that makes sense, why I'm eliminating this, type in a 1. If it makes sense, then type in a 1, because the outcome is categorical. Our outcome is continuous. Okay? It's continuous. Multiple logistic regression, used to assess how well two or more independent variables predict a categorical dependent variable. Our dependent variable or outcome variable is not categorical. It's continuous, right? We go back up here and we see that it's continuous because it's a scale. So it's a continuous interval variable. So therefore, multinomial logistic regression is out. Okay. And then factor analysis, used for data reduction. We don't say anything up here about data reduction. There's nothing in here about data reduction. It looks at predictor. Didn't say anything about data reduction. So that's out. Okay, we're going to be done in about 10 minutes. Okay. So that's out. Now, so what's left? Multiple regression. This procedure tells you how well two or more independent variables, right? We've got two right here, two continuous independent or predictive variables, predict a dependent outcome variable that is continuous. It's continuous. And we see that's continuous. So we come down here and we type in multiple regression. If that makes sense, type in a Y. If that makes sense, type in a Y. Okay. Okay. If you have any questions, don't be afraid to ask. You know, don't if you look over this and you have some questions and you think about things after the class, send me an email. You know, and if some of you are, if you watch the video again, some of you have access to the replays. You can pay. I mean, I'm sorry, you can get access to replay and you watch it again. You have some questions. Don't hesitate. Don't hesitate to reach out to me. All right. Then they got the last research question. Is there a difference in optimism among younger, middle-aged, and older participants? So now we go to the differences page where we're looking at tests that deal with differences. All right, so let's look at the first one. Use when you want to know if there is a significant difference between a sample mean and a test value. We don't say anything down here about a sample mean and a test value. We're not interested in that. So that's not it. So one sample t-test, that's out. Independent sample t-test. Appropriate when you want to compare the mean scores between two groups. All right, so let's say mean scores between two groups. So is there a difference in optimism among younger, middle-aged, and older participants? That's three groups. That's not two. So this one is out. Okay? That one is out. Dependent or paired samples t-test applies when you have one group of subjects or matched pairs where data is collected from this group over two different time periods. So that's like a pre-test and a post-test. We don't have any information over here about a pre-test or post-test. We're not asking about that. We're asking about optimism scores between three groups, three age groups. So that's not it. All right, that's not it. Next, assess whether there is differences in the mean scores between three or more groups on a continuous variable. So you got one categorical variable with three or more categories. One, two, three. Let's go back up here, right? So you got three categories: younger, middle-aged, and older. And that's a categorical variable. And then you've got the dependent variable that is continuous. And the dependent variable is optimism scores, and it is continuous. So it looks like that one's looking pretty good. All right. So this one's looking pretty good. So we're going to bold that, and we're going to go to the next one. Allows you two-way factorial ANOVA. Allows you to simultaneously test the effect of two or more variables on a dependent variable. We have one variable, and that is age group. These are age groups. That's one categorical variable. Age group 3, that's one. If we had another one, then that would be 2, but we only have one, and we've got a continuous variable. So that is out. This is out. Repeated measures allows you to simultaneously test the effect of two or more variables on a dependent variable. So, oh, we've already done that. Okay, repeated measure. Use when you have one group and data is collected from this group over 3 different time periods or conditions. So let's say you're trying to test a pre-test, post-test, and then a follow-up. We're not doing that. We're not interested in that. That's not what the research question is. So that's out. Okay. Next, we've got a mixed design ANOVA. This test combines the repeated measures ANOVA and the between subjects ANOVA. We're not doing repeated measures at all, so that's out. We already crossed out the repeated measures, so we know that this is not it. Analysis of covariance. Used when you want to determine if there are differences between mean scores when controlling for a covariate. We're not controlling for anything. There's nothing in here about control. We're not controlling for anything. The word control is not in that research question. If the word control is not in your research question, anything related to control is automatically crossed out. So the only thing that's left is the one-way ANOVA. So that's what we have. We've got a one-way ANOVA. So those are the 3 tests that we're going to run in this analysis. So this is what you would do when you're analyzing your data. And this is, we just finished phase 1. Okay. So we just finished phase 1, and tomorrow we will start phase 2. All right. Are there any questions? Okay. Are there any questions? If you have a question, just type in the queue and I'll bring you on, or you can ask it or whatever. Now, while you all are getting your thoughts together, some of you are asking to buy the workbook and to get the replays. Okay. Now, the web page said if you didn't buy right then and there, the price was going to increase. So it was $47 for the workbook and $97 for the replays. And it was going to go from 47 to 97, and then 97 to 197. But I'm going to give you a few minutes to upgrade. Okay? I'm going to give you a few minutes to upgrade, because you should be paying the higher price, but I'm going to give you, it's 9:15. I'm going to give you until 9:30. So I'm going to put the link inside the chat. Okay? So let me put the link inside the chat. And then I'm going to give you 15 minutes to make your purchase. Hold on one second. And then after that, you're just going to have to pay the higher price. So let me get the link, and then we can go from there. So I'm going to put the link inside the so the way it works is okay, so let me ask this question. Who is interested in buying the workbook? Type in a W if you're interested in buying the workbook. Okay. If you're interested in getting the replays, type in an R. Okay. Got it. Got it. Okay. So let me give you the link. Okay. Some want both. Okay. All right. So if you want the replay, I'm going to type replay only. This is going to be the link for the replay only. Okay, that's for the replay only. If you want to buy the workbook by itself and the replay, if you just want the workbook, I'm going to send you a link. If you want the workbook and the replay, you can use that same link. You just buy the workbook first, and then it's going to ask you if you want to buy the replay. So I'm going to give you that one. So I'm only going to give you 15 minutes now because I'm going to shut it down after that, and you're going to have to pay the higher price. Okay, so if you look in the chat, I just put in the links for the replay and the links for the workbook and the replay. So you buy them one at a time. Okay, so I'm only giving you I'm only giving you 15 minutes. Okay, so it's 9:20, 9:45. I'm gonna shut it down. Okay. Because I gave you all a chance, and I'm not trying to be funny, but I gave you all a chance, and you all, and I get it, some people like, so if we pay for the workbook only, now we have to pay $97 for the replays. Is that correct? Yes. If you already purchased the workbook and you want the replay, then you just pay the $97 only. Yes, that is correct. So I put in a link for the replay only, and then those who didn't purchase the workbook, you can get the workbook only, or you can get the workbook and the replay. Okay. Now, I'm gonna so for those who get the replay, I will have the replay up in about 2 hours, and then you will get an email indicating that the replay is available and that you can get it, and so on and so forth. Yeah, that you can access the replay, and I will send out an email tomorrow or later tonight that will have the link. So the way it works is I send you out an email 1 hour and 15 minutes before the workshop starts. Okay, and that's when I send out a link for you to join the workshop, or to the link so that you can join the 8 o'clock. So we're going to start at 8 o'clock tomorrow, and then we'll go from there. Okay, so it's going to be 8 o'clock Tuesday, Wednesday, Thursday, Friday. We take the weekend off, and then we come back on Monday, and we come back on Tuesday. Okay? Anyone have any questions? So on a scale of 1 to 10, how helpful or how helpful was this this first workshop on a scale of 1 to 10? Where 1 is not at all helpful and 10 was extremely helpful. Okay. You're not going to hurt my feelings. I've been doing this for almost 20 years. You're not going to hurt my feelings. It's okay. Yeah, so again, if I'm here to help, okay? If you have questions, I'm here to help. You're not going to find a person who is as accessible as me. And I'm going to tell you something else. I didn't really publicize this, but if you purchase the workbook and the replays, you get a free 30-minute session with me. After all this is over, if you're analyzing data, if you want to throw something, have a conversation with me about a project you're working on, you get a free 30-minute session with me via Zoom, one-on-one. So I put that out there too. Okay. All right. So I'm going to be on here until 9:45. Would you cover sampling design and sample size estimation, as we need to cover that before we get to this stage of research? Sample size estimation, we need sampling design that's a whole course in and of itself. Now, there is a software called what is it called? What's the software that I use? G-Power. What I'll do is, G-Power. So what I'll do is maybe I'll get some videos. I'll find some videos on YouTube, or put some videos myself on G-Power. No promises, because that's really beyond the scope. This class is for people who've already have their data or will have data. And then, because that comes way before this, that's another class. This is strictly data analysis. Okay. That's another class. But more people want the data analysis class than they want the research methods class, the sampling design, all that kind of stuff. But I'll consider that, but this is a data analysis class. Let's see, any other questions? Let me see here what people are doing, because I'm only going to be on here until 9:40. All right, so that's basically it. I'm going to turn off the recording. Let me see. You're very welcome. I'm going to turn off the recording so that I can begin working, so that I can have an opportunity. You're very welcome. Thank you. You were a great audience. And I look forward to seeing you all tomorrow at 8 o'clock. And if you're watching the replay, some people purchased only the replay, right? They're only watching the replay. So if you purchase the replay and you have questions, please don't hesitate to email me. If you purchase the replays, you have access to the replays for 12 months. So you can email me anytime. Email me anytime. Okay. That's one of the benefits of getting the replay. You can email me anytime. All right. Okay. I'm going to be online